All right. Thank you for joining us on today's webinar, How Wi-Fi 7 and Multi-Link Mesh Will Revolutionize Home Networking. My name is Ben Stone, and I'm with RCR Wireless News. In this webinar, Nick Kucharewski, SVP and GM of Wireless Infrastructure and Networking at Qualcomm Technologies Incorporated, will outline how the new Qualcomm Immersive Home Wi-Fi 7 platform is set to deliver immediate performance benefits for both legacy devices and the newest Wi-Fi 7 connected devices. As a note, the webinar and slides will be made available for download after the presentation today. Please be sure to enter any questions that you have for Nick during the presentation as well, and we will do our best to answer them or follow up with you after the webinar via email. With that, I'm pleased to give you Nick.
Great, thank you very much. And good morning, everyone. Thanks very much for joining our presentation today. And we'll be talking to you about the technology and features in Wi-Fi 7, and most importantly, how those features can be applied to the next generation of home networking. Very excited to do this today. Let's get started. So first of all, a bit about Qualcomm. Many of you may know us through our work in cellular networking, but perhaps what might be less well known is that Qualcomm is also a leader in Wi-Fi connectivity. In fact, Qualcomm is #1 in global Wi-Fi shipments when you look at both router devices, access points, as well as connected clients such as your phones or tablets and PCs. Since 2015, Qualcomm has shipped 6.5 billion Wi-Fi connections. Now let's look a little bit at the trends happening in the home and why there's a requirement for a next generation wireless network. The first key trend is broadband access. Specifically, all of us at home are having access to faster broadband connections. We have seen a progression from perhaps 1 megabit or 10 megabit connections up to 100 megabits, and now we're seeing gigabit connectivity going into the home. More people worldwide have access to high-speed fiber, and we're seeing new technologies like 5G fixed wireless access. So home networking connectivity is getting faster. #2, the applications we're running in the home network are changing. When you look at that broadband internet, 71% of that traffic is today used for video streaming. We're talking about 4K video, the emergence of 8K video, and other high bandwidth real-time streaming. Second, we see gaming traffic as a significant contributor. That's 11% of total broadband traffic. Gaming is significant because it demands high bandwidth, but it also requires a very fast response time. We're also seeing new applications such as two-way video. In the last 3 years, we have seen a change in the way people work from home, the way they take meetings, perhaps the way they go to school. And this is about two-way video where you're broadcasting and receiving video, and you expect real-time communications. Looking at the statistics, since 2020, Microsoft Teams has seen a 250% increase in the amount of user activity on that platform. And that really speaks to the change in the way that we're using the network, the way we're using that internet access. Third, we're seeing an expansion in the number of devices connected to the home network. Every year, we see more and more devices connected to Wi-Fi. This is both high-speed devices like your television or your phone or your tablet, but we're also seeing IoT devices and home automation devices, or Wi-Fi connectivity for consumer electronics, to the point where today in the United States, the average household has 22 devices connected to the Wi-Fi network. That's a significant change from a few years ago when you were talking about perhaps only a handful of devices. So those are the 3 key trends impacting the home network. Now let's talk about how these trends impact the requirements for the network, how it changes the type of features and the type of equipment that you will need for next generation Wi-Fi. First of all, to take advantage of that high-speed broadband link, you need to be able to propagate that bandwidth everywhere within the home. And this is about having not only range or simple connectivity, but it's having connectivity at speed, so that if you're getting a 100 megabit broadband connection, or perhaps even a gigabit, that can be propagated all the way to the farthest reaches of your home. And that's really a significant requirement for next generation Wi-Fi. Number two, the emergence of these new applications, such as high bandwidth streaming video, low latency gaming, or real-time two-way communications. This places demands on the network in order to give you a good experience for those new applications. Now, in our view, this comes down to two key performance metrics. The first one is speed. It's about bandwidth. It's about how do you propagate that high speed to any one device who's using that application. The second one is about latency. Now, in the parlance of the average user, latency translates into low delay or the absence of lag or jitter. When you experience high latency, that translates into a non-realistic experience that might be jittery, it might be delay. So if you want to have a good experience, it's about providing low latency in addition to high speed. And the third requirement is the ability to connect to a large number of devices of all different types. When you're talking about an average of 22 devices connected to the average home Wi-Fi network, some of those devices are very high speed, some of them are slow speed, some of them have the newest Wi-Fi technology, some of them have older or legacy Wi-Fi. But because wireless is a shared medium, we're all sharing the same airspace, those slower devices can actually impact the performance of the higher speed devices sharing that same spectrum. So it's a question of how can you build a network that will provide the best performance for the highest speed devices while also providing connectivity for slower devices, and that you can provide a great experience in a crowded network. So these are the three key trends and the key requirements that are affecting next generation home connectivity and that drive a need for a new generation of equipment. So with Wi-Fi 7, Qualcomm and the industry have been working on solving many of these challenges. Wi-Fi 7 is really about a suite of technologies that provide tools for equipment manufacturers to provide a solution to solving these key network challenges within the home. And today we'll be talking in more detail about each of them. So talking first about Wi-Fi 7 and some of those features, those building block capabilities that help solve these problems. First of all, Wi-Fi 7 provides for faster connections. Specifically, it has expanded the maximum channel width from 160 megahertz in Wi-Fi 6 to 320 megahertz. This means the channel is twice as wide, and roughly speaking, you can put twice as much data across that wider channel. Secondly, Wi-Fi 7 allows for higher order modulation. What this means is you can actually put more data across the wireless in a specific point in time. This is in the form of a larger number of symbols that are encoded across the air. 4K QAM is new in Wi-Fi 7, which means that in any point in time, there are one of 4,000 symbols being communicated. That translates to a 12-bit value, which is 20% higher than what was available in Wi-Fi 6. So these two features really translate into faster connections and being able to push more data. The second key feature is Wi-Fi multi-link, and this is about providing multiple connections between two devices. For example, in Wi-Fi 6 or before, if you were communicating between two devices wirelessly, you were doing that across one channel, across one radio station, effectively. But with Wi-Fi 7, you have the ability to establish connections between devices using multiple channels at the same time. You can communicate across both of those channels simultaneously. You can alternate between them. You can choose a number of different ways to make use of multiple channels interconnecting devices. And we'll talk a lot more about the key benefits this can deliver at the network level. The third is that connections in Wi-Fi 7 are more adaptive than they were before. One example of this is a feature that we call adaptive interference puncturing. Now, this is a very technical name, but actually it's a simple concept. When communication is happening in Wi-Fi networks, you occasionally could have interference, but that interference may happen in only a portion of that channel. For instance, if you're communicating at 320 megahertz, you might have interference in only a small part of that 320 megahertz band. Now, in the past, you would have to cut the channel in half in order to avoid that interference, or you can cut it in quarters if it's happening somewhere towards the middle. But now with interference puncturing, you have the ability to carve out that interference and use the entire rest of the channel. That means that you can have more high-speed connectivity even in the presence of interference, because you're not chopping down the width of the channel to avoid it, you're actually going around it, you're carving around it. So these are 3 examples of key new features in Wi-Fi 7 that can provide for higher speed connectivity that is more adaptive. Now, talking a bit about the products available in Wi-Fi 7 today. So earlier last year, Qualcomm announced the FastConnect 7800 series. This is a Wi-Fi 7 product intended for client devices, for instance, in your phone or tablet, consumer electronics devices. In May of last year, we announced the Networking Pro Series Wi-Fi 7. And this was a chipset and software package specifically defined for routers and access points. And this was about delivering Wi-Fi 7 features for an enterprise network or a pro-grade home consumer application. Both of these products are in production now from Qualcomm, and we're available to our partners for shipping in the mass market. Last month, we announced the 3rd in our Wi-Fi 7 product family, and that is the Qualcomm Immersive Home Platform Wi-Fi 7. And this is about taking those features that we've developed and that we've brought to market and deploying them in a form factor that is well suited for the home, that is in a compact form factor, that is power efficient, and that is built specifically for solving the unique problems of connectivity within the home that we'll be talking about in more detail today. The Immersive Home Wi-Fi 7 platform is about providing extremely high throughput with support for those real-time applications, your video streaming or your two-way real-time communications or gaming, in a package and form factor that is really purpose-built for home and retail applications. But perhaps most importantly, the Immersive Home platform rolls out multi-link mesh using Wi-Fi 7. This is a system level and a network level approach to applying Wi-Fi 7 features to enable better and faster home networking. This, in our view, is the most significant new feature in the Wi-Fi 7 line when you talk about home networking. And it has the potential to revolutionize the experience of Wi-Fi connectivity in the home. Now, that's a bold statement. So let's talk in a little bit more detail about how that's possible. So first, I wanted to talk a bit about mesh networking. For those of you who might not be familiar with it, this slide hopefully will fill in some of the details. So here we have a picture of an example home. You have a broadband connection coming here at the bottom. This could be DSL, PON, cable, or it could be wireless, for instance, fixed wireless access using 5G connectivity. In any case, all of this goes into the mesh root node that we're showing here on the first floor of the house. Now, with a mesh network, you have more than one Wi-Fi network device. Beyond the mesh root, you have the mesh satellite. This is an example of a 2-node mesh networking system. Now, between the mesh root and the mesh satellite, you have what's called a backhaul link. This is a Wi-Fi connection between these 2 devices, so it's sharing the same Wi-Fi communication medium, and it exists purely to transfer traffic between the root and the satellite, or from the satellite to the root. So if you have internet traffic coming in from the broadband link, the root transmits it to the satellite, and then the satellite propagates it to the final devices. Or if you're sending traffic to the internet, that path is reversed. So then connected to the root, you see a number of clients, for instance, a television set, a car, a tablet. All of the first floor devices are connected to the root. In the second floor of the house, all of the client devices are connected to the satellite. So this picture shows really an example mesh network. And it also kind of shows why mesh networking has become so popular, because you're now providing high-speed connectivity to all of the devices in your home, because every device has a fairly short path to their nearest mesh node. Second-story devices are very close to the satellite. First-story devices are very close to the root. They all have great connectivity. And with a high-speed backhaul connection, you can really transfer that broadband traffic to the satellite and then send it to the connected clients. So now with this picture of how mesh networks are done today, let's talk about how it's different through multi-link mesh. So to depict this, we've taken that picture from the previous slide and plotted it a little bit differently. Here, we're actually mapping wireless spectrum. At the bottom, we're showing the legacy channel. This could be, for instance, 2.4 gigahertz. And connected to the legacy channel, you have some of your older devices, you have some of your slower speed devices. So here we're showing cameras or light bulbs or a thermostat connected to that 2.4 gigahertz channel. In the middle, we're showing the high-speed channel. Now, commonly, this is 5 gigahertz. It's a wider channel. It operates at higher speed. And a lot of devices today support 5 gigahertz. For instance, here we're showing your phone, tablet, a PC, a television set. Some of the higher speed streaming TVs support 5 gigahertz. And then you have, for instance, an AR headset or newer applications. And then finally, you have the backhaul channel. This could be a third channel, and it might be a second channel operating in the 5 gigahertz band, or it could be a 6 gigahertz channel, which was first made available with Wi-Fi 6E. In either case, this third channel is being used for the backhaul. So that connection between the mesh route and the mesh satellite is happening across the backhaul. So this is the typical deployment model for what's called tri-band mesh. So when someone's referring to tri-band mesh, they're talking about these 3 channels, one for the slower speed devices, one for the high speed devices, and a dedicated backhaul channel. So now with this picture that shows the way mesh is deployed today, tri-band mesh is deployed, let's talk about multi-link mesh and how that's different. So the first thing we've done here is we've replaced the dedicated backhaul and the dedicated high-speed client with high-speed channel A and high-speed channel B. We're viewing those as 2 channels which are high-speed, which can be flexible in the way they're deployed. The latest generation platform is very adaptive in terms of how it makes use of these wireless resources. And everything else remains the same. So in normal operation, you'll still have things operating as they were before. But now the network can be made adaptive to specific traffic types or specific events happening within the home. For instance, say you are downloading an operating systems update. So this is a very high bandwidth transfer that needs to happen as fast as possible. And you want to see it happen using the most of your broadband link that you can. Well, here, the network can make use of 2 channels simultaneously for connecting between the mesh route and the mesh satellites. So instead of just using one backhaul channel, you're using 2 channels for the backhaul connectivity. So this way, this file download can be translated from the broadband link across the backhaul to the satellite node, where it can then be sent to the final device. So you're getting a burst of higher speed using simultaneous multi-link. Or 2 high band connections, 2 very high speed connections at the same time for the backhaul channel. So now also another thing that we'll see within the home is interference. So if you're like me, when you turn on your Wi-Fi network and look at networks, you might see a lot of your neighbors' networks nearby, neighbors on either side or across the street. If they are simultaneously using the internet, if they're using the same wireless channels, then that interference can actually slow down your network because they're transmitting and really colliding across the same channel. Now, in the past, this could mean that your application is slowed down. Either you get slower speed or you start to see delay because you have to wait for the other transmission to complete before you can communicate. Well, multi-link mesh provides a way to avoid such an event and to continue to provide high bandwidth and low latency. So here we start with, again, the conventional operating model, and we see an interference event. For instance, the neighbors communicating. In this case, we can dynamically switch to the second channel so that the backhaul link can continue transmitting, except no longer using channel A, it's using channel B, and it's using it where it needs to avoid that interference event. Now, in real terms, this means that any delay that you would have experienced because of that other transmission from the neighboring network it has been eliminated because you've simply steered around it. Metaphorically, it's a little bit like driving in traffic. If you see a backup in the lane in front of you, you simply steer around it, choose another lane, and keep going on your way. So what's really significant here is that these benefits are made available to the Wi-Fi 7 network itself. The mesh network is performing faster. It's providing higher speed and lower latency. But this is happening regardless of whether you've actually upgraded any devices in your home to Wi-Fi 7. The network itself is faster, which means moving to Wi-Fi 7 allows for a faster network even before you've upgraded your devices to Wi-Fi 7. So these are significant implications. So now let's take another event which might happen in the home. For instance, a device is communicating with the router, but there's interference on the high-speed channel B where that device is connected. So if you have a Wi-Fi 7 device, then that device itself can hop over to another channel. So that interference not only impacting the network, but impacting those devices can be avoided because those devices can hop to the other channel and continue to communicate. So here also, you're avoiding that delay, you're avoiding the lag that would come from that interference and continuing to operate at deterministic, low latency, high speed. So now let's go back to that home network and talk about the benefits in real terms of these new features of multi-link mesh. So in this case, we're showing the same topology, and you have replaced the mesh route and the mesh satellite with Wi-Fi 7 devices. You've replaced Wi-Fi 6 with Wi-Fi 7. Now with that upgrade, you can see up to 3.5 times higher bandwidth capacity of the network itself. This means the network or the infrastructure of Wi-Fi connectivity in your home can burst up to 3.5 times faster. This is because we're using wider channels, going from 160 megahertz to 320 megahertz. And we're also making use of that two-chain or two-channel capability, where you can burst using simultaneous high-band multi-link in order to complete those transactions. The second key benefit is that the devices themselves can operate faster. In fact, a single device can see twice the speed at a typical distance. Here also, we're comparing to a Wi-Fi 6 device that's operating at 160 megahertz to one which can operate at 320 megahertz, or one that can operate with multiple channels of 160 megahertz. So twice the speed at the same distance. And third, the Wi-Fi 7 multi-link mesh network can show a reduction in real-time latency for these applications. In our tests, we see a 75% reduction in latency when operating in the presence of interference. And this comes from the ability to steer around those interference events. So it really means the entire network can be made faster, and you have higher speed connectivity, and you are more resilient to interference from neighboring networks. Now, talking back at the application again. So these benefits at the network level can translate into better experiences for real-time applications. For instance, if you're talking about a gaming application, often in the past, high-speed gaming has relied on using a wired Ethernet connection. Well, here with multi-link mesh and Wi-Fi 7 devices, you're seeing a significant reduction in latency because you can avoid those type of events which would slow down a wireless network. That 75% real-time latency reduction translates into better real-time gaming, better two-way communications, and altogether a more resilient network that begins to approach the behavior of a wired network. Second, this multi-link mesh can bring us closer to the vision of providing quarter-to-quarter gigabit performance in the home, taking that high-speed broadband link and expanding it and extending it everywhere in the home. And this really comes from higher speed to devices no matter where they're connected. In the lower right corner, we're showing a traditional mesh network built on Wi-Fi 6. And you might find, for instance, 2 gigabits per second when you're operating very close to the nearest mesh node, and then 1 gigabit per second further away, and then it gets lower and lower speed as you get further away from the mesh node. Well, with Wi-Fi 7 multi-link mesh, you could see higher speeds when you're right next to the mesh node, but the distance at which you can achieve gigabit speeds has become larger. So that means you can extend that gigabit connectivity further and further from the mesh nodes within your home. This translates into higher speeds for devices wherever they're placed within your home network. So now let's talk a little bit more about the Qualcomm Immersive Home Wi-Fi 7 product line, which we announced last month in December. So there are two members of the family, the 3210 and the 326. Both of these product platforms are tri-band systems. That means they allow for connections in the 2 gigahertz band, in the 5 gigahertz band, and for regions that support 6 gigahertz, also in the 6 gigahertz band. For regions that don't support 6 gigahertz, we can enable a second 5 gigahertz channel. Our focus on tri-band systems really speaks to the benefits of Wi-Fi 7. In our view, you really require a tri-band system in order to make the most of Wi-Fi 7 capabilities, such as high-speed multi-link and those very wide channels that can be made available in 6 gigahertz or multiple channels in 5 gigahertz. So with the 3210, we provide for 3 simultaneously operating channels. One of them is 2x2, and the other 2 channels are 4x4, which means those are higher bandwidth, longer range connections. In the 326, all 3 channels are operating with a 2x2 wireless configuration. And this is more suited for a very compact form factor for higher node mesh networks where there's a focus on providing a broad connectivity through high density mesh. Now, with these 3 channels, we can provide the maximum channel width offered on each channel worldwide. So for instance, our 2.4 gigahertz channel operation maxes out at 40 megahertz, which is the maximum spec allowed. Our 5 gigahertz operation maxes out at 240 megahertz channel width, and our 6 gigahertz band operation maxes out at 320 megahertz. So for every one of those channels, we can offer all the way up to the limit in terms of what's possible in Wi-Fi 7. So you get the fastest connections for any network deployment in any region of the world based on what is enabled in those regions. As I mentioned before, our goal was to deliver a product line which is purpose-built for the unique requirements of home networking. Now, I already talked about a lot of the network level features and why it's special for the home, but this is also about the form factor. It's about power consumption. It's ultimately about the cost. So we've tried to deliver a solution which is enabled in a compact design that offers low power consumption. Now, talking a bit more about these concepts, our focus was really about system design optimization. It's not only about the features, it's about how do we enable a full system design that is very efficient. And we can show that with a very specific example. On the left-hand side of the slide, we show the Networking Pro 620, which we announced in May of last year. And here we show a tri-band 2x2 configuration, and there is a representative printed circuit board showing the Qualcomm chipset. And here on the right-hand side, we show the newly announced Immersive Home Wi-Fi 7. Here also in a tri-band 2x2 configuration. And here you see a reduction in chip count, reduction in the size of those products, a reduction in scale of that printed circuit board size. And that enables our customers to build platforms which are smaller, more power efficient, more compact, making them very well suited for the next generation of Wi-Fi mesh networking. Now, it's not only about the hardware, it's also about the software. And the key point to note here is that the way that systems are being brought to market is changing. We're now seeing an emergence of open source network operating systems and software middleware layers so that the systems equipment manufacturers can now build a system using a combination of their own software, of Qualcomm's silicon and software, and also these open source operating systems and middleware layers. And the key is we're developing support for a number of third-party ecosystem partners developing these open source network OSs, and middleware layers. This is part of the roadmap of software support that we'll be making available in the coming months and quarters for the Immersive Home Wi-Fi 7 platform. So in summary, we talked a lot about the new features in Wi-Fi 7, how it enables higher speed connections, how it provides a more adaptive network that can react to interference events, to traffic in the network. And we've talked about innovations happening not only at the chipset or device or feature level, but also at the network level, where the use of Wi-Fi 7 features applied at the network level means that you can provide a significantly better experience for the home user. In real terms, this is about providing bandwidth to the further reaches of the home and to providing deterministic low latency, which is so critical for those next generation applications like high bandwidth streaming, gaming, and emerging applications like AR and VR. And of course, the focus is to provide this in an optimized solution, which is highly modular, which is compact, and is cost effective for the next generation of retail, as well as carrier deployed Wi-Fi 7 networks. So through our announcement last month, a number of systems manufacturers worldwide have endorsed the Immersive Home Wi-Fi 7 approach. And here you see logos of companies in Europe, in North America, and in the Far East, who are all embracing these Wi-Fi 7 concepts and the vision to provide better connectivity for home users. Now, the products that I've talked about today are either in production, in the case of the Fast Connect and the Pro Series, or in the case of the Immersive Home Platform, we are now sampling to our systems manufacturing partners. We anticipate that, that these partners will be bringing systems to market sometime beginning in the second half of 2023. Of course, that's dependent on their own manufacturing schedules. Based on our timelines, we expect that you will begin seeing these systems in commercial deployments towards the end of this year. So that concludes my presentation today. I hope you will find that Wi-Fi 7 can really have the potential to revolutionize home networking when viewed at the network level with these type of innovations that can really provide high bandwidth connectivity throughout the home with deterministic low latency. Thank you very much for your time. Any questions?
Great. Thank you so much, Nick. So I'll start with this one. The 6 gigahertz spectrum band is not necessarily available in every region or varies in total size available. How does this impact Wi-Fi 7 capabilities?
Sure, that's a great question. So as I mentioned, with our high bandwidth channel support, we can offer you to have the third band be 6 gigahertz, or we can offer systems manufacturers to build systems with 2 channels in that 5 gigahertz band. So for instance, you can picture a tri-band network that has 2 gigahertz, 5 gigahertz, and 6 gigahertz, or you can picture a system that has 2 gigahertz, 5 gigahertz, and then another 5 gigahertz channel. So what this means is a lot of the innovations I talked about today can be available even in those geographies throughout the world that have not yet licensed 6 gigahertz operation. The point is we provide those flexible options that make this a very well-suited product, regardless of where in the world it's being used. Of course, with 6 gigahertz operation, you'll get the highest performance and the highest throughputs.
You mentioned Wi-Fi 7 network can help Wi-Fi 6 or Wi-Fi 6E devices, even if the user doesn't have Wi-Fi 7 devices. Could you please elaborate a little bit more on that?
Sure. So in our analysis of tri-band mesh networking, I showed the ability for the mesh backhaul network to burst to use 2 channels or to alternate where it can switch between 2 different channels. This has the impact of speeding up the entire network, where you can get a burst of higher speed through the network, or you can avoid interference and provide deterministic lower latency for the network. All of those network level benefits can improve the experience for all the devices that are connected, regardless of whether those devices are Wi-Fi 6 capable, Wi-Fi 5, or Wi-Fi 7 capable.
Great. And with Wi-Fi 7 devices like phones or laptops just starting to come out, how do you think about interoperability?
So as I mentioned, a lot of these benefits at the network level are available to legacy devices. So of course, our newest router chipsets can provide support for older devices. So interoperability is really provided. Now, what you get with a Wi-Fi 7 device is further improvements in performance so that the highest speed devices take advantage of those latest features. And also, I think it stands to note that these network level benefits that are offered with multi-link mesh are also available to clients that are connected regardless of the technology that they're using. So what we find is what's really special here is that some of these benefits are both available to older and newer devices, and it also provides interoperability where different devices of different technology can also make use of some of these network level benefits.
Great. So 250 megahertz on 5 gigahertz bandwidth, how is that possible?
Yeah, so this is referring to my slide where I showed 240 megahertz operation on the 5 gigahertz band. So this is an interesting one because a lot of us have been focused on the 6 gigahertz band, which was newly licensed for use in Wi-Fi, and how you can get a very wide 320 megahertz channel in 6 gigahertz. But I think what might be talked about a little bit less is how we can also provide a speed up on that 5 gigahertz band, which is already licensed today. Specifically in Wi-Fi 6 and before, you had a maximum of 160 megahertz operation in that 5 gigahertz band. But with Wi-Fi 7, we've taken that to 240. You get 50% more speed for a channel operating in that 5 gigahertz band. And this is available in countries or regions throughout the world where you have enough frequency spectrum in 5 gigahertz to support that. We support that through a combination of the advanced DSP implementation in our product, where we can provide that wider channel specifically for those regions that provide sufficient spectrum in the 5 gigahertz band.
And what impact do Wi-Fi 7 features have on access points range?
I'm sorry, could you repeat the question?
What impact does Wi-Fi 7 features have on an access points range?
Oh, on range. So I think when we talk about range, we can look at two different attributes. The first is how far away from the router do you remain connected? Meaning if you have a router or a mesh node and you keep walking further and further away, at what point do you lose connectivity altogether? The second way of thinking about it is when I am, let's say, 20 feet away from the router, how fast is my connection? Now, I think a key point to note is that with multi-link mesh and the concepts we talked about here, when you are, let's say, 10 feet or 20 feet away from the router, you can achieve a higher speed connection than you could with Wi-Fi 6. If you have a Wi-Fi 7 client that supports high band simultaneous or 320 megahertz channels, you can get higher speed at a given distance. And I think that's probably the most significant impact of Wi-Fi 7 for client devices. Now, there are also a number of elements which can improve the range, the absolute range or the maximum connectivity range, but we haven't really talked too much about those today. It's probably a topic for a more deeper discussion, perhaps in another forum. Thanks very much for the question.
Yeah, of course. When will new Qualcomm-based systems based on the Immersive Home Platform be available to be Wi-Fi 7 certified?
So certification is another question. So as you may be aware, so the systems coming out today with Wi-Fi 7 capabilities have not yet become certified as Wi-Fi 7 because that certification process has not yet begun. I would refer the audience to the appropriate standards bodies, the IEEE and the WFA, for their current timelines and when they would anticipate that certification would happen. I do anticipate it would be sometime after these products are first available in the retail market. So stay tuned for that.
Great. And is there any advantage specific to Wi-Fi 7 for wireless fixed access services?
I'm not sure if I follow the question.
We can move on. How many high BW low devices can Wi-Fi 7 support?
I'm trying. Could you repeat EW low?
Sorry. How many high BW/low devices?
Oh, how many high bandwidth devices, low bandwidth devices? What we're seeing is in this generation of devices, the number of connected devices is consistent with our previous generation devices, meaning the absolute number, or the maximum that you can connect, is comparable to what you have seen in the previous generation. And it's a complex question because this is based not only on our silicon support, but also our customer software. So in terms of the maximum number of connected clients, as it were, this will be a equipment specific specification. So depending on the manufacturer that's providing the equipment, we want to check those specs. But the broad message is that between our previous generation and the current generation, we have maintained the same number of connected devices in terms of the absolute max. But as I already mentioned, some of these features make sure that you have a better experience when you have a high number of connected devices.
Great. Is multi-link mesh a Qualcomm proprietary feature, or will it work with devices from other silicon providers?
Yes, so good question. So as we talked about, perhaps what's so exciting about the feature is that the benefits it provides at the network level can be experienced for all of the connected devices. When you're talking about speeding up the network itself, or providing deterministic low latency for the network itself, all the connected devices can take advantage of that, regardless of the vendor. But in terms of the specific innovation of multi-link mesh, this is a combination of our silicon support for the feature combined with specific implementation algorithms for how we handle those channel resources. And because we're talking about a network level innovation, the implementation itself is about the communication between Qualcomm devices that comprise that multi-link mesh. So the short answer is it's a combination of proprietary innovations that give you better performance at the network level with the capability to interoperate with clients that come from any technology vendor.
Super. Is Wi-Fi 7 more beneficial for home networking or enterprise and/or industrial uses?
Yeah, it's a great question. So Wi-Fi 7 itself provides a suite of capabilities that can improve the network experience for all Wi-Fi networks in the home, in the industrial, in the enterprise. It provides for higher speed, wider channels, and it provides for adaptiveness through multi-link and through adaptive interference puncturing. This translates into higher speed connections. It also means that there is an opportunity to provide deterministic low latency. Now, the way that we use those Wi-Fi 7 features is highly dependent on the network level implementation, network level algorithms that are being applied to translate those Wi-Fi 7 features into a network level experience. But suffice to say, all of those capabilities are directly applicable to connectivity for all of those end market applications.
Awesome. Have you done any testing on using MLO capabilities to deliver the same packets over multiple links in order to increase the reliability of the packet delivery instead of only for increased bandwidth? If not, do you have any thoughts on the topic?
Yes. So by and large, a lot of the testing that we've done, or the charts that we've prepared, are speaking about two specific attributes. One is using multi-link for higher throughput, and this is broadly speaking aggregation, using multiple channels to send something faster. The second one is using multi-link to avoid interference in the name of enabling low latency. What we haven't prepared is charts about how multi-link can help with resilience, or actually can help with a more reliable communication channel. I think it's an interesting question, and we'll take that back to the team, and perhaps in a future presentation, we can talk about the implications of these type of features for reliability and guaranteed delivery? It's a great question. We'll need to follow up on that.
Awesome. And does Wi-Fi 7 allow outdoor operations?
So it does allow outdoor operations now, but with one caveat, and this is around the 6 gigahertz channel. With the 6 gigahertz channel, you first need to make sure that there are no incumbent devices already using that 6 gigahertz channel. For instance, there are other devices that are not Wi-Fi that may be approved for use in that 6 gigahertz band. If you go outside, you need to make sure that you're not interfering with them inadvertently. So in order to address that concern, the industry has been working on a capability called AFC. And the idea behind AFC is to first check if there are any incumbent devices before you operate in the 6 gigahertz band, or to determine how much power that you can apply to your transmitter in that 6 gigahertz band. And this involves polling a server that will tell you if there are any incumbent devices connected. So in order to address this, Qualcomm has prepared a full suite package offering that will provide for AFC support for our partners developing Wi-Fi 7 solutions, as well as Wi-Fi 6E solutions. This is a product that we announced in May of last year. We call it the AFC Cloud Platform from Qualcomm, and it's available for customers to integrate and then to test to enable 6 gigahertz operation outside or indoors at high power. Thanks very much for the question.
Yeah. What's the difference between your two families of products, the Pro and the Immersive Home?
Yes, so the Networking Pro series is about applying Wi-Fi technologies for enterprise applications and also for carrier and retail applications that require very high performance. So the scalability of the line is such that you can do higher bandwidth, higher throughputs, higher numbers of connected devices, and in a form factor that really can provide the highest possible performance. With the Immersive Home series, we've taken a lot of those same core technologies, that same core architecture, and applied it to the unique home application. So it is scaled down in a couple of attributes in order to make a more compact design, in order to enable lower power consumption, but the same core benefits of Wi-Fi 7 are there. So this is really about whether you're talking about an enterprise grade or a prosumer grade versus a straight home retail application. And that's really an approach that we followed for several generations, where the requirements of this enterprise grade and a home class product can be a little bit different, and the expectations for power consumption and size might be different.
Great. So we've seen a significant drop in pricing for Wi-Fi 6E and 6E mesh systems over the last few years. Should we expect a similar trend here, i.e. high-end premium home mesh systems, very expensive in early days, and then rapidly moving to lower prices?
Sure. So in general, that I think accurately depicts how we see technology transitions within the Wi-Fi space. If you go back to Wi-Fi 5, Wi-Fi 6, Wi-Fi 6E, those initial products might be premium flagship products, and then you eventually see those same technologies appear in the broader market at lower price points. Perhaps the difference we're seeing here, that with the Wi-Fi 7 Immersive Home Platform, we're bringing our home optimized product to market fairly soon after our Pro Series product was brought to market. What that means is we see an opportunity to accelerate that pattern or that path from where you start with high performance Wi-Fi 7, perhaps at a premium price, to then seeing Wi-Fi 7 more broadly deployed within the home. So the Immersive Home Platform is very much an effort to enable those Wi-Fi 7 capabilities to the home user, perhaps more quickly than we saw in previous generations.
Okay, great. And can you characterize what interest from broadband carriers in Wi-Fi 7 and or next-gen mesh Wi-Fi looks like?
Yes, so speaking in general terms, the benefits of Wi-Fi 7, I think, are readily apparent. We see higher bandwidth connectivity, more resiliency, deterministic low latency, and that's certainly attractive to the enterprise space, to the retail space, and also for carrier routers and gateways. So I think there's going to be deep implications for manufacturers and providers in all of those verticals. And in terms of the specifics, it's hard for me to comment today on exactly when you might see them for instance, from your broadband provider. But suffice to say, I think Wi-Fi 7 is very exciting, and I think the attributes are becoming very well understood throughout the industry.
Okay, great. Well, it looks like that's all the questions that we have for today. So I just want to thank our audience and thank you, Nick, for your presentation today. This concludes our webinar.
Great. Thanks very much. I really appreciate it.
Super. Take care.
Have a great day.
Thanks.